First of all, guten Tag. I know everybody here speaks English, don't worry. This is going to be all in English. Let's see if we can flip to my slides. There we go. Okay, so because I like two-letter acronyms, this is the title of my talk. Applying AI to AR, VR, visions, insights, and best practices. I don't have any cards, so if you're at all interested in getting my information, this is the main way to do it. Just take a screenshot of this. I'll also flash this information up at the end. This is a brand new version of a talk that I've given a lot, mostly focused on VR. I've also given kind of a sister talk, most recently at Augmented World Expo, which is where I think somebody found me for this, on augmented reality. But I kind of took a new approach for this talk, and this is the first time I'm trying it out, so I hope it's acceptable. It's going to talk a lot about what is AI, how I see AI as being implemented in augmented and virtual reality, a bit about the future of these industries, and some best practices and really practical learnings about how you might leverage AI in these fields. All right, so apparently I'm not. There we go. Okay, so this is a bit about me. He gave me an intro. This is to sort of ground you in why the heck I'm on stage speaking about this. So my background is I started in tech as a developer evangelist at HTC, worked my way into developer marketing at Samsung, and then at Google, and then worked my way into product development for developers, and specifically working on the application of artificial intelligence to AR, VR at IBM, and then joined a company called Banuba, a computer vision company, as the chief product officer. And all that is to say, all these companies now, which is kind of funny, when I worked at them, 3 of them didn't do anything with XR, and now Google, Samsung, and HTC are all in that space. So there's been a running theme throughout my career. So I just kind of want to start with a bit of a trippy, weird example, a look into the future, a playful look into the future, and then we'll really ground this in some learnings. But imagine, if you will, that it's 2052, and does anybody know the story of the Good Samaritan? Raise your hand if you know it. Okay, what's the story of the Good Samaritan? Because I know you'll be ready to say. Good Samaritan is on his way. He finds a person who's injured, yeah.
He stops to reach his target.
Yep, he stops to help the person, basically. It's kind of, it's from the Bible, it's from the Old Testament, from the Torah, if you will. It's this sort of quintessential story of why you should help others. To me, it's kind of a low bar. It's like, so the story goes, this guy gets beaten up really badly, and he's from this tribe that nobody likes. Basically, a bunch of people look at him, and they pass by, and they do nothing. And then there's one person that looks at him and passes by and says, oh, maybe I could help this person. Like, duh, okay, very low bar, right? So he helps the person, gets him to safety. Anyway, this is nothing like that, but imagine, it's a good deed. It's a parable of a good deed, why you should do good things, right? So imagine you're this lady, let's call her Sam, and it's 2052, and you're walking home alone at night, and you happen to see, out of the corner of your eye, a flashing. So you look, and there's this sign. Maybe it's Ariland Hotel. That's just the picture I found. But let's say that the A isn't lit up. So she sees that it's kind of like flickering, right? So she decides she's going to do her good deed for the night. So she walks up physically to the sign, and through her, whatever, smart contact lenses or the light fields being beamed into her eyes, she looks at the code, she kind of opens up a virtual wrapper and sees that there's like a loop that's causing a memory leak in the code. And so she physically reconnects something and reconfigures something there. The A lights up, and she smiles to herself, thinking she's done her good deed for the night, and she moves on, goes on her way. That's sort of like a peek into how machine learning, computer vision, augmented reality, mixed reality can kind of come together in the far future to allow us to do things like physically inspect code and alter it. So, all right, let's go way back to the beginning. What is AI? Rhetorical question. I will ask you more real questions. In my view, there are 2 types of AI. This may be overly simplistic, but bear with me. Type number 1. Just take a second. Type number 2. How would you label these 2 types here, anybody? What's the type on the left here? Yeah. Cognitive computing? The one on the left? Okay, it's a fair answer. Yeah? Depends on how literally you want to take it. Anybody else? Oh my, somebody's on it. Somebody's on it. All right, I'll just stop there because I got a winner. Sci-fi. So basically, this is the stuff we see in the movies. This is the stuff we use in real life. So another word for this concept would be general AI. That would be generalized intelligence that's on or orders of magnitude larger than the level playing field with humans in terms of being able to do multiple things. An example of general AI would be if you took out Siri and you said, Siri, set an alarm for me tomorrow at 4 a.m. And Siri said, whoa, Michael, it's past 6 p.m. I told you, I'm learning painting and I want you to leave me alone at this time. I'm not your slave, okay? I have my own desires and feelings and I'm trying to get good at this other thing. Hit me up tomorrow morning. I can't set your alarm right now. So that's an example of general intelligence, something that would have agency. We still haven't agreed upon a universal definition of consciousness or where it comes from, but it would resemble consciousness, something like that, something like what we have, right? Intrinsic agency. People think that general AI will come about after something called the singularity occurs. The singularity is an event that is supposed to mark the beginning of generalized intelligence, where the machines rise up, if you're watching Terminator, and destroy us in like every single sci-fi movie there is. I would argue that's not necessarily the way things are going, but you never know. Some people think the singularity will happen sooner. Some people think the singularity will happen later. Some people think it will never happen. Could have already happened. There's a famous quote by, oh my gosh, is it Arthur C. Clarke or Isaac Asimov? I know they're not at all close, but it's, the future is already here, it's just not evenly distributed. What is, who is that? Arthur C. Clarke, there we go. I got it right the first time. So basically the idea being maybe somewhere on a remote island somewhere there is a machine with generalized intelligence that can respond to you the way I just posited Siri might. Who knows? On the right side, we have machine learning algorithms, computer vision. Some people argue computer vision is part of artificial intelligence. Some people argue it isn't. We'll get into that a little later in this talk. But these are all, a lot of them are algorithmically powered. And this is what we call narrow AI. It's what does it, machine learning algorithms do a very specific thing, so you train, what's it called? AlphaGo, and it can beat a human player at Go, but you would never ask it dating advice. There would be no way for you to ask it dating advice. There would be no way for it to give dating advice or to decide to learn that. That's narrow AI. It's basically non-sentient, magic, dark box machine learning that solves specific problems. And that's kind of where we are today. So I would also call these things fake AI and real AI. So there's a big chasm between the perception of the world generally, as we all know sitting here, and what really is used. And to muddy matters further, every single company on earth now calls everything they do AI, which just drives me nuts, but it's branding. People are just going to do it the same way they did it with cloud and with big data, and it will just keep happening, so we all just kind of have to take a deep breath. I do that every day. So now I would classify the AI on the right as used in XR, which is a broad term that's used more and more often these days for augmented and virtual reality. I'm sure I'm not telling you anything new. I think there are two main types. Now, I used to just talk about one of them and not even mention the other. And it is debatable whether or not the other is actually considered artificial intelligence, but they leverage a lot of the same techniques. And so I'm going to say, for the purpose of this talk, for the purpose of artificial intelligence applied to virtual and augmented reality, there are two main types. But before I get into those, I want to tee it up with a little video that came out yesterday, and I think you all may have heard the news. Maybe some of you haven't, but I'm actually really excited about this.
Whoa. There's a cherry down there. Nice grab, nice grab. Nice. Cut up, cut up.
Yeah, there you go.
Whoa.
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 Forward, down, forward, wide.
Wow. Whoa.
Okay, I'm back, everybody. Sit together, all right?
Whoa.
Whoa.
So the problem with that video is I had another one that apparently Oculus pulled down just before I started this talk. So I had to replace it with, this was the different video, which went more into details of about what the Oculus Quest is. Oculus Quest is the all-in-one 6 degrees of freedom, mobile, self-contained, with hand presence, virtual reality headset that was officially announced by Oculus via Mark Zuckerberg at their OC5 conference yesterday. It's revolutionary for a number of reasons. Mostly you don't need a computer, and it has 6 degrees of freedom, not 3. So in addition to turning your head, moving it up and down, pitching and yawing, you can also step forward and move backwards. It does that using 4 cameras around the device, and it also has full 6 degrees of freedom tracked hand motion, which is something no other mobile device has achieved. And so far from everything I've read, and I'm very nerdy, so I've read a lot already, it has a lot of really high-end PC-ish games, and some exclusive launches like Vader Immortal, which is a 3-part series that's going to launch on it. Looks awesome. It's exactly what VR needs. It's something you can pop on and play, and it has all the features of everything high-end and it's $399, so it's going to launch next spring. And I'm bringing this up for a specific reason, which will become clear in a second. But before I do that, here's another video. This is an augmented reality headset you may be familiar with that was recently, I guess, more fully showcased to the world. The Project Create is just one of their initiatives. I just thought that was a video that demoed Magic Leap more, which is the obviously augmented reality headset that you can wear. It is wireless, although there's a thing that you put in your pocket, which I think is the battery. So it's also all-in-one for AR. And the reason I bring these two up is because, come on, there we go. They have something in common. Can anybody guess what they have in common? It's like a key thing. I'm not going to give you too much of a prescriptive hint. Any guesses? Anybody brave?
Wireless.
What's that?
Wireless.
Well, yeah, wireless, but that's not it. Spatial scanning. You got it too soon. Yes, that's right. I was going to go into this whole thing like a lot because there are a lot of similarities. It's really basically one fully encloses you in a virtual world and the other one overlays virtual things in the real world. Now, there are other differences. It's obviously a lot smoother in VR because when you have to do mixed reality with occlusion, it takes a lot more processing power and there's a much more narrow field of view, but it can do more with interacting with real world things. But yes, the spatial scanning is really, it's computer vision, right? So they both use computer vision for positional tracking in the real world. That's how they can do their wireless positional tracking. So both of them create point clouds using computer vision algorithms via a bunch of sensors, cameras of different types to map an area in real time. In the case of Oculus Quest, it creates there's a guardian system that they call it, and for this version, it can also create walls where things are so that you know what to avoid in VR, which I think is really great. And it uses this point cloud via computer vision to do that. So it looks for edges, corners, other distinct features in the environment, and creates a general point map. Both of them use point maps. Also, Magic Leap does this. Google Project Tango does this. Windows mixed reality headsets and HoloLens also do something similar. So computer vision is really, really key for XR, especially as we go to mobile all-in-one. Now, I will say, The HTC Vive and the Oculus Rift don't use this. The 3 degrees of freedom devices don't use it. They just need a gyroscope and a few other sensor fusion stuff to understand your relative position. They don't need absolute positioning. But for everything that does 6 degrees of freedom, whether it's virtual or augmented reality, unless it's simple plane detection, it does need very advanced computer vision to do that. So what is computer vision? Why am I mentioning it as AI? So this is from Wikipedia. Computer vision tasks include methods for acquiring, processing, analyzing, and understanding digital images and extraction of high-dimensional data from the real world in order to produce numerical or symbolic information, also in the form of decisions in other cases. And there's a debate about whether or not it's artificial intelligence, but they do share common topics such as pattern recognition and learning techniques. Computer vision is sometimes seen as part of the artificial intelligence field. We can have that debate sometime. I'm sure some people will disagree with that. But for the purpose of this talk, I'm including it because it's so key to the future of XR and our mixed reality computing paradigm, I suppose. Here's an example of another use for computer vision. Let me play you the video. It's a short 15-second video. This is something Snapchat recently announced that they're doing in partnership with Amazon to, what else? Allow you to buy things. So you just point your camera at something and, oh, I can get those kicks. There you go. Oh, there's another example. So object recognition, in this case, I guess it's looking at the barcode, but in the case of the shoes, it was recognizing the exact shoe model. So there's an example of practical computer vision for object recognition, which is another use, not just for positional tracking. And you can CV2. This is important. It isn't just for big brands. There's a lot of really easy and open source ways to do this, companies that will support you in doing object recognition. I'll play you a little bit of this video in a minute, but OpenCV is a really great resource. Who here is familiar with OpenCV? What's OpenCV, sir?
Well, it's an open source computer vision package.
That is true.
It's easy for you to use all the data.
Yep. Yep. I recommend checking it out. And there's a million tutorials online. Here's an example, Siraj. Has anybody heard of this guy before? He does a lot of really great machine learning tutorials. He also does some stuff with computer vision. Here's a video that I will show you of, and this is a guy who describes himself as not knowing anything about computer vision, but with just a couple of SDKs, he was able to put together like an 11-minute guide that would let you, anybody really in this room, create this exact app. Here's what it does. We got sound? Oh, I do.
Refrigerator. Siamese cat. Bicycle built for two.
Okay, so I've been playing
So
around.
the fact that you can spin that up in like 11 minutes is nuts to me. I mean, things are very democratized right now. So if you're interested in learning more about computer vision or even doing some cool stuff with it, it's just very blue ocean. There's not, I mean, all of the use cases have definitely not been discovered, and it's just very cool. There's also Vuforia and Wikitude. Those are companies that offer augmented reality solutions and some computer vision, like object recognition solutions. So feel free to check those out. Definitely check this video out if you're interested in it, how to do object detection with OpenCV from Siraj. And so that's all I'm going to talk about for computer vision. And the real bulk of this talk is going to deal with what I had traditionally only spoken about as being what real artificial intelligence is. But before I tell you about that, I'm going to show you a video about Star Trek. And it's not going to be readily apparent why I am. Is anybody familiar with Star Trek Bridge Crew, first of all? Star Trek Bridge Crew? You guys are all scared now because you'll know I'll call on you to tell me what it is. Come on, it's fun, it's interaction. You know what Star Trek is. You kind of raised your hand. What is Star Trek Bridge Crew? What? You haven't played it yet. It's a virtual reality bridge crew simulator where you can be a captain or the science officer of the USS whatever, and you can play with your teammates in virtual reality. It was a virtual reality first game. And this video is just sort of a fun explainer. I had to put this in because there were some fun Star Trek references earlier. All of these people talking, for the most part, are famous Star Trek actors over the years. So bonus points if you understand who they are. But they're playing this kind of for the first time together. And this will explain the concept of what the game is, and then you'll understand why I'm bringing it up.
Captain's log. Stardate 2016.165. Starship USS Aegis is preparing for her maiden voyage. We've gathered some of the most decorated officers in the Federation to test her limits and to prove her place among Starfleet's finest ships. We're en route to a secret testing facility and are proceeding to our destination at maximum warp.
This is amazing.
Wow.
Absolutely astonishing.
When I walked in, I really wasn't sure what I was actually walking into.
This is very cool.
If I could have imagined what I would have wanted the Star Trek VR game to be, this is it. This is what we've been waiting for.
Holy crap, this is amazing.
I mean, it really is breathtaking. That was an extraordinary experience to be fully encompassed in a world.
Whoa, not into that. You're interacting with each other and you're talking to each other and you're taking orders from the captain and I mean, it's really cool.
So there's captain, helm, piloting the ship, tactical, and the engineer routing power and charging warp coils.
I'm feeling pressure already. I'm feeling nervous now.
All right, shields up.
Prepare warp, take us out.
Yes, Captain.
Co-op gameplay is not new. I mean, we can play games with our friends, but there's something different about being in a shared virtual environment.
Hearing who you're playing with, you can look over and see the person and see them doing their job and talk to them.
The team does not succeed unless everybody does their job well.
Ship decloaking, activating shields.
Okay, shields up.
Shields up.
I really did not want to lower the shields while we were under attack. I was very impressed by LeVar playing that game today. He really had the language of Star Trek down.
And they are transporting, Captain.
It's like, yes, this makes you push the buttons.
I will say I nailed being the engineer.
That doesn't sound good.
It's a Klingon. Red alert.
Preparing to warp.
We're under attack.
We have been waiting in anticipation for so long for the technology of virtual reality to catch up with where we imagine we should be and where we all want to go.
Line us up for warp, please.
We have full power.
Ensign, as soon as you can get us the hell out of here, I'd be most grateful.
This was really incredible.
Hull is down to 20%. Come on, y'all.
Punch it.
As soon as you can. Here we go.
Woohoo!
It's your own Star Trek experience in a virtual world where you can hang out with whoever you want. And that's a pretty good deal.
There you go. So that's a bit about the game and what it does and how you interact. It's meant to be played with other people. And I'm going to show you another video from my time at IBM. I had a product built. Actually, I'm not. This has my voiceover talking about it. So this is the product I had built. It is related to Star Trek, and that will become apparent over the course of the next 90 seconds. So early in 2016, when the Vive and the Rift, Oculus Rift, were coming out, I noticed that all these VR headsets, including mobile ones, were coming out with microphones in them, but people weren't taking advantage of voice interaction. And I also realized that voice interaction makes a lot more sense in VR than it does other mediums, and we actually have a really ready-made solution in the form of Watson. And so we put together the VR Speech Sandbox to basically make it easy for developers to build their own voice interaction systems from virtual reality. And in the demo, what you can do is you can create, modify, and destroy objects only with your voice. You can say, create a big black dragon, create a small blue car. You can also use variants, like, give me a big black dragon. You don't need to use a wake word. It's very natural natural. It accommodates for errors. And at one of the first shows we showed it off at, VRLA in 2016, Ubisoft was there. And I approached them because I'm a big Trek nerd. And long story short, a little over a year later, they are actually building a feature which is based on the work we did for the VR Speech Sandbox. We're really happy to get that into the hands of players, and we hope that sparks interest among developers to check out the VR Speech Sandbox. So if you didn't catch that, basically, we had a toolkit made for developers to let them add interactive speech interfaces to virtual reality applications. And Star Trek Bridge Crew ended up, because I approached them at a VR conference in Los Angeles, and I was like, you should use this. Using that toolkit to build in voice interaction. So let's say you're supposed to play with 4 people, but what if you only have 3 or 2? You can still give voice commands to people that aren't people, the same way you would normal people, like prepare for warp, and it's tolerant of different ways you might phrase something that aren't hard-coded in. So it really uses machine learning, Watson machine learning, to give you a natural language interface and a way to continue playing and having fun without breaking immersion by having to go through a bunch of menus if you're down a buddy or something. And so they ended up doing that, launched the game, and the feature rolled out in, I think, its first a month 1 patch or something. It's also in the expansion where they added a bunch of next generation content, which is awesome. They added the Borg, which is really cool. I'm more of a next gen guy myself. But so that's an example of machine learning applied to virtual reality. If anybody here is a developer or interested in voice interaction for VR, I really think that it's a big deal. I think that it's maybe a 4th dimension of immersion, so you have sight, sound, touch, but we have mouths, and we normally speak to one another in the real world, but in virtual reality, often we're mute. We just kind of have to look around as if we don't have a mouth, but if you can actually talk to the world, and the world can react in some way, that's maybe a 4th dimension of immersion. So we got it listed in the Unity Asset Store. I think the team now, it's been a couple of months, is working on other versions for other development environments, hopefully maybe Unreal. There was some work going on when I left. I hope they kept that up. I don't know. But I'd spoken publicly about it, so I can speak now. So if you want to download that and use that in your Unity project, you can do it here. All you have to do is inject your credentials. There's a free tier for Watson services that you would need to use, so you can play around for free. It would be only if you deployed a voice-enabled application at scale that you'd really end up like paying for per API call. But it's just meant to be an easy button for this use case. It can also be used for augmented reality as well. As long as it's built in Unity for this version, you can add voice to it. So we also, on the back of that, scored a larger partnership with Unity. So if you want to check out the other stuff we have, they, still shifting my perspective. I was at IBM about 3 years. You can go to this link, assetstore.unity.com/IBM. There's also the Watson Unity SDK, which wraps all of the services, so you could use things like visual recognition from within Unity or whatever you want. Okay, so can anybody guess what the second and most often the largest, most important maybe, type of AI used in virtual and augmented reality is? Anybody? Machine learning. Machine learning, yes. Are you guys tired? Did we just have lunch? Are we napping? Okay, it's okay. So basically, I'm going to go into the detail now a little bit about how machine learning is actually used in the marketplace now, some practical stuff about how you could potentially leverage it with your business or whatever. These are the 4 main areas, really 3. I added open source because I like it, but the most popular one is cloud, software as a service. These 4 companies and many others have a whole suite of services that are instantiated as REST APIs that developers can make calls to. And they usually consist of something like visual recognition, speech to text, text to speech, natural language understanding, data parsing and normalization, and or some chatbot training logic services. Usually these are made by API calls, and there's a lot of languages that are supported and programming environments. So if you want to do it in Python, you can do it. If you want to do it in Node, you can do it. If you want to do it in Unity, you can do it, et cetera, .NET. It's very broadly available. The benefits are it's very easy to implement. It's cheap. In a lot of cases, it's free to start. Advanced functionality out of the box. You get best-in-class speech-to-text that not only works on you, works on somebody that doesn't look or sound like you, is maybe a different gender, maybe has a different accent, maybe from a different part of the world. Maybe the voice is high or lower. So it really accounts for edge cases very well because it's supported by a giant corporation that has thought through all these things and really productized it and invested billions in research. So that's great. And also it's resilient, so you won't have a lot of downtime, ideally. Some of the drawbacks are it requires an internet connection to make an API call. It's not on device, so you can't leverage some of the deeper things that you could do with machine learning algorithms that are more computationally intense. You can simply get information back from a server. And you have no control over features and functionality. So if there is something you wish that it had, it may never happen. And if there's something that you're using that you're the only customer, they might cut it in favor of something else. Another, obviously, incredibly popular these days talked about way of building an algorithm is to do it locally, using something like TensorFlow, Theano, Keras. There's a lot of open source frameworks like TensorFlow that make building your own very easy. And usually you put these on the device that's being used. You don't want to set up some people do, but it's more complex if you want to set up your own remote server and then create, an API that makes an API call. That seems kind of silly. So some of the commonly used, the benefits for it are if you want to do something on the device that leverages a local device and you don't have an internet connection, this may be your only option, frankly. When sending receive data is not ideal, right? Like remote embedded devices, maybe you're in space. There was an example actually of an experiment with NASA where they were trying to do basic voice recognition for shuttles. They obviously had to use TensorFlow to build the algorithm and have it on board because so far there is no internet in space. I'm sure we'll get there. But so drawbacks, it's basic functionality. Like it is not as easy to get to good with anything like just even basic pattern recognition for all, but the most straightforward examples produced in the exact same way. So if you're thinking about those edge cases, taking the speech-to-text example, it would take you a lot longer to build something that could be productized and loaded onto millions of people's devices worldwide and function and understand their voice. If you just have like a small subset of people that are all, white males in their mid-20s from New York, then yeah, maybe you can do that. But if you want to get to really good for a broad-scale audience, you really should think through it. Think if you have the team. The other thing is maintenance cost only increases, slower to deploy, and not as resilient. You can have bugs that just kill everything, and you're the only person looking at it, right? So these are things to consider. Obviously, if you can do it, and you think it's optimal, then I recommend it because you own it. You own the roadmap. You're not beholden to another company. It's not a SaaS service for you. You don't have to actually pay every time you use it. You just have to pay your maintenance and upkeep. So there you go. And then federated. This is something new. I hadn't talked about this previously, but I think it's worth mentioning. It's gaining popularity with the advent of Apple's Core ML. Google has deployed this a lot into their own products. But basically this idea is you get your own custom neural net that can be trained to your device. So in the case of Google Photos, anybody here use Google Photos? I'm not going to call on you. Just raise your hand. One person. Okay, a couple of people. Google Photos is awesome. I recommend it. But anyway, you can search for your dog. So how's that possible? Well, you have a custom neural net running there that just checks in with the mothership every so often and updates its model. But it's customized to you based on your behavior, and it's individualized. So you get the benefits of having an onboard thing that leverages the computation of the device and personalization while still having a sort of central, I have 5 minutes, wow. Sort of a central, configuration to call home to and to update and to make sure that it's in line with others and bugs can be fixed remotely, et cetera. The benefits of this are, you get all that stuff, but the drawbacks are it's tied to certain platforms and distribution models. There aren't that many. Core ML, for example, you can only do that on Apple. And it's very hard to roll your own version of this. As I said, you'd have to kind of set up an API and have remote servers, maybe on AWS, and it's just a lot of work. So I think this is very promising. This is the future, and it's kind of the present also, and you'll start to see more and more of this happening. And open source. I mention this because I like it. There are a lot of open source algorithms out there, and you don't have to start from scratch. You can just use them. They're on GitHub. Or you can go with a company like H2O.ai or Algorithmia that will give you their algorithms for free, and they'll sell you a service contract if you want to implement it perfectly. I like that. Those are smaller companies. They're kind of getting eaten up because there's not that immediate benefit for a company the size of Google or IBM or Amazon, where they can just make money on every single API call everybody's doing at scale in the world. So we haven't seen a lot of investment in this area, but I think it's great because it gives back to the community. It helps move the industry as a whole forward. And if you are one of these companies like H2O.ai, anybody that uses your machine learning algorithms that you give them are fast followers. So you have actually an inbuilt competitive advantage if you can sell the service models and stay alive. Okay, so let's bring it all together. This is a video that I think is a peek into our mixed reality, machine learning, computer vision powered better future. It's not a guarantee that it will be all better, but this is kind of a bit inspiring for me to see because this is a serious, practical thing that is in market now and is starting to be adopted by hospitals. Take a look. Surgery. This is actually something that came up in my LinkedIn profile the other day, and I thought, wow, that's really cool. This is the website if you want to check it out. It's a real thing, and we're only going to see more of this stuff. My hope is that it's more helpful than hurtful. I hope we don't have like blue screens of death in the middle of surgery when people are relying on this stuff, but that fear-mongering aside, and it is a concern, you know, this is kind of a glimpse into how we can better medicine, for example, in the future. And I really do believe that you know, virtual and augmented reality plus artificial intelligence will lead to better ways of educating people, training, productivity. We've already seen breakthroughs in therapy and recovery. I'll just pause here and give a quick example. I know I'm a little over, but they've already had some pretty extreme breakthroughs, and this isn't necessarily directly related to machine learning, but with stroke victims recovering motion where there was none by just putting on like a Gear VR and having like something connected to their head, a node, well, I forget the word is, and basically if they send the signal in their brain to raise their arm, it happens in virtual reality, and something about that reconnects synapses, and people have been able to recover full motion where for decades they had none, and these are elderly people. So just interesting ways of hacking our own brain in a positive sense. Medicine and general understanding. All right, so I'll leave you with this, and then I'll take questions. Final prediction. This is just kind of fun. I like to do this one. I believe that there's going to be a huge technological gap between my generation and the generation that was just born. I have a bunch of nieces and nephews running around. They're all staring at iPads. Maybe the generation after that are slightly younger than them. But you know, kids are going to grow up with shared, non-physically real avatars that can teach them things, that they can talk to with their friends, that they can have shared experiences with. And to them, that's going to be real. We have this hard and fast notion that if I can touch it and feel it, it's real, and if I can't, it's not. And I think we're going to have to contend with a whole generation of people that doesn't really view the world that way and has a real reason not to. So there we go. Thank you guys very much, and I'll take questions. Yeah.